Alright, so today we're gonna be looking at the remainder factor theorem. So basically, if I have a number, let's say 11, and I divide it by 5, I end up getting 2, which is known as the quotient, and 1, which is known as the remainder. And now notice that the remainder here is divided by this number, the divisor. And so if we simply apply this to polynomials, let's say I have a polynomial q of x and I divide it by linear factor x minus a, I'll end up getting again the quotient and the remainder divided by this part, the divisor. And now if I multiply both sides by x minus a, we end up with q of x equals x minus a times the quotient plus the remainder. And now let's see here. Let's see if we're told to find the remainder when a polynomial is divided by, let's say, x minus 3. Let's say x minus 3. So we know that we can write it in this form where a is simply 3. And so if we find the polynomial value at 3, then this part becomes 0 because x is 3. This part becomes 0. 0 multiplied by anything is 0, and therefore we're simply left with the remainder. And let's try this in a problem. Let's try this. Okay, let's say we have x cubed plus 2x squared plus x minus 2, and that is going to be our polynomial, and we're told to find the remainder at when it is divided by x minus 4. So we can say that this part can simply be written as x minus 4 times the quotient plus the remainder. And so if we say let x equals 4 here, let x equals 4, this part becomes 0, this part, and so we're simply left with the remainder. So let's work this out. 4 cubed will be 64 plus 2 into 16 plus 4 minus 2, and this gives us 64 plus 32 plus 4 minus 2. 64 plus 32 is 96. 96 plus 400, and we're left with 98. And this was basically the remainder theorem. So let's take a look at the factor theorem now. So what is a factor? Well, basically, if I have a number, let's say 30, and I divide it by 5, we know that I'm left with 6, and in this case the remainder is 0, and therefore 5 is said to be a factor of 30. Now if we apply this to polynomials, q of x divided by x minus a, where x minus a is a factor, we end up with the quotient plus the remainder, which is simply 0, so I'm just going to erase that. And so now if we multiply by x minus a on both sides, we can see that the whole polynomial is simply the quotient times the original factor. And now we can do some pretty cool stuff with this. Let's say that they tell us to evaluate the value of a in an expression like this, and they tell us x minus 2 is a factor. So we can say that this is the original polynomial. So I'm gonna write that as q of x equals x minus a, in this case a's value is 2, times the quotient. And so now we can see that if I simply input x equals 2 into this equation right here, then this whole part, this right hand side, becomes 0, And so we're simply left up with a whole equation and one constant. So we can find that, right? So let's try this. Let's say x equals 2. So q of 2 will be 2 cubed, which is 8, plus 2 squared, which is 4, so 4a, minus 3 times 2, which is 6, plus 2. And so if we simply equate this expression to 0, we'll end up with 4 plus 4a is 0. And so we can now see that a is simply -1. And this is why the remainder factor theorem is actually pretty useful in real life.